Right, in lesson 19, we're going to start with the topics of exponents and roots. There's another part to lesson 19, which is evaluation of powers, which we'll talk about after we've introduced exponents and roots. Now let's take a look first of all at the expression of 3 squared, or I could also say this as 3 raised to the second power. Now, if I were to evaluate this, I'd ask myself what 3 times 3 is, and the answer to that is 9. So remember, the exponent tells the base, the big number, how many times itself it's multiplied. If I had 3 to the third power or 3 cubed, you take 3 times 3 times 3. So again, the exponent is telling the big number how many times itself you're going to multiply it. 4 squared would mean 4 times 4, or in other words, 16. And this is kind of the basis as we go into some of these examples that I'll show. Now in example 1, we're asked to evaluate a -2 squared. Now, it's really important to understand the meaning of the parentheses here. So, before I continue, let's take a look at this expression. Whatever is inside the parentheses, I'm going to square. So let me say that again. Whatever is inside the parentheses, I'm going to take to the second power. So this means, let's see, a -2 squared means a -2 times a -2. And I would get an answer of a +4 because a negative times a negative is positive. So since the -2 is in parentheses, I'm going to take the -2 times a -2. Now likewise, if I had a -3 cubed, what's this mean? Well, whatever is inside the parentheses, I'm going to take times itself 3 times. So I'd have a -3 times a -3 times a -3. And in this situation, let's see, a -3 times a -3 is 9. And then 9 times a -3, I get a -27. So notice I'm really emphasizing the set of parentheses. Now in example 2, notice it looks like the same type of problem, but it's really not. I don't have parentheses here. There's a big difference here between example 1 and example 2. So the way I do example 2 is, first of all, let me state how you would read this correctly. We're going to take the opposite of 2 squared. I'm going to take 2 and square it, and then take the opposite of it. Notice there's not any parentheses, so I'm going to square the 2. I'm going to square the 2 and then take the opposite of that. So what is 2 squared? It's 4. What's the opposite of 4? -4. Likewise, another example, if I had the opposite of 3 squared, I'm going to square the 3, which is 9, and then take the opposite of 9, -9. So if I had a -2 in parentheses squared compared to the opposite of 2 squared, there's a big difference between the meaning of those two. Let me show you one more example just to emphasize this. Think about the opposite of 4 squared. Think about what that answer would be compared to a -4 squared. Which one of these two is the answer a -16, and which of them is a +16? Well, let's take a look. Let's start with the left one. On the left one, I'm going to take it wants to know what the opposite of 4 squared is. So square 4 is 16, then take the opposite of 16, that's a -16. In this case, I get a -16. Now, how about if I had a -4 squared? Whatever's in parentheses, I'm going to square it. So this means a -4 times a -4, and in this case, I get a +16. All right, in example 3, now we've got a combination of examples 1 and example 2. So the first one, I want to know what the opposite of 3 cubed is. Cube 3, take the opposite of it. Minus whatever a negative 2 squared is minus 2 squared. Alright, so in the first part of this expression, I'm going to take 3 and I'm going to cube it. So 3 times 3 times 3 is 27. Now take the opposite of 27, that's a negative 27. Minus, now whatever's in the parentheses I'm going to square. So I'm going to take a negative 2 times a negative 2, that's a positive 4. So minus 4. Minus, what's 2 squared? 4. Alright, now let's figure out what, let's calculate what our final answer is. So 27 and negative 27, take away 4 more is a negative 31. Take away 4 more is a negative 35. So our final answer, our final value, is a negative 35. Alright, the next part of the video is what we call roots. Now, we just got done with exponents. Now we're doing roots. And if you remember in the past, if you were asked for the square root of 4 or the square root of 16 or the square root of 9. Alright, what's the square root of 4? What number, what's this asking? Well, it's asking what number times itself will give you 4. And the answer is 2. Now, before I go on any further on this, let's take a look at the symbol for the square root. It's kind of that hook shape, right? And really, I could put a 2 in there if I wanted. But we usually don't have the 2 in there because whenever there's not a number in the hook, for example, over here I've got a 3 in the hook. When there's not a number in the hook, we know that that's asking for the square root. So in other words, what number times itself would give you 4? 2. What number times itself would give you 16? 4. What number times itself would give you 9? And that's 3. So the square root of 9 is 3, the square root of 16 is 4, and so on. Now, what's the difference with this one? Here it's asking for the cubed root. What number times itself 3 times would give you 8? So in other words, what number could I multiply times itself 3 times and get 8? Well, the answer is 2, because 2 times 2 times 2 is 8. Alright, in example 4, they're asking for the cubed root of a negative 64. Now, there's one new thing that I've added here, and you've got that negative symbol inside there. So in other words, you know it's going to be a negative number. So what negative number times itself 3 times is going to give you a negative 64. So you just got to start with a number. Maybe try a negative 2. Let's see if that works. Let's see, a negative 2 times a negative 2 is 4. And what's 4 times your negative 2? That's a negative 8. So that's too small. So let's try a little bigger number. So I'm going to erase this and let's try a negative 3. Now maybe that'll work, or maybe I even have to go higher on that. So I'm going to try a negative 3 times a negative 3 times a negative 3. Right, a negative 3 times a negative 3 is 9, and 9 times a negative 3 is a negative 27. So it's still too low. Alright, so we'll try a negative 4. Excuse me, so I have a negative 4 times a negative 4 times a negative 4. So a negative 4 times negative 4 is 16. 16 times a negative 4 is a negative 64. So my answer is a negative 4. So the cubed root of a negative 64 would give me a negative 4. Alright, example 5, combination of powers and roots. Now let's take a look at the first part. The numbers in parentheses. So whatever's in parentheses, I'm going to cube it. So I'm going to take a negative 3 times a negative 3 times a negative 3. Let's see, a negative 3 times a negative 3 is 9. 9 times a negative 3 is a negative 27. Plus, now notice these kind of relate to one another. I know that a negative 3 times itself 3 times is a negative 27. Now here they're asking that. What number times itself 3 times would give you a negative 27? Well, the cubed root of a negative 27 is a negative 3. So now I add these together. Take away 27, take away 3 more. I've taken away 30. So it's a negative 30. Alright, our last example, example 6. Again, a combination of exponents, or in other words, powers, and roots. Alright, so on the first part, I'm going to take 3 and square it, which is 9, and then take the opposite of that. So 3 squared is 9, take the opposite of 9, that's a negative 9. Minus, what number can I take times itself 3 times and get a negative 8? Let's see, what number times itself 3 times would give me a negative 8? Alright, I'll start with 2. I'll try a negative 2. Let's see, a negative 2 times a negative 2 is 4. 4 times a negative 2 is a negative 8. So the cubed root of a negative 8 is a negative 2. Minus, what's the square root of 16? What number times itself is 16? It's 4. Now I can simplify this a little bit before I come up with my final answer. Minus minus is plus. So now let's see, 9 degrees below 0 goes up to, that's a negative 7 minus 4. Now take your negative 7, so you take away 7, take away 4 more. My final answer is a negative 11. So our two topics have been exponents and roots, and these are all part of lesson 19, and after this we will have one more topic involving lesson 19.